Mr. Beck does your homework. This is homework number 3, question number 6. It asks, a car traveling at 6.6 meters per second accelerates 3.0 meters per second squared to reach a speed of 16.0 meters per second. How long does it take for this acceleration to occur? So let's see what we know. A car traveling at 6.6 meters per second. Stop. There's a number with some units. 6.6 meters per second is what the car is initially doing. So I'm going to write that my V0 equals 6.6 meters per second. It accelerates at 3.0 meters per second squared. Stop. Meters per second squared, that is definitely an acceleration unit. So 3.0 meters per second squared is my average acceleration. So I'm going to write it down. To reach a speed of 16.0 meters per second, well, that's sometime later on. The car is now going at 16.0 meters per second. That is a velocity. It's in meters per second, and that's my final velocity is going to be 16.0 meters per second. So here we've got a car that starts out at one speed. Here's my car. Give it a wheel. It starts at 6.6 meters per second. Some time goes by, and that same car later, with that same funky front wheel, but now it's stretched out for some reason, is going at 16.0 meters per second. And it's accelerated at 3.0 meters per second squared. It's gone faster and faster and faster. That gives me a positive acceleration in this case. So going from a positive to an even bigger positive is a positive acceleration. How long does it take for this acceleration to occur? I'm looking for time. Time equals question mark. Now I have a relationship that says that my acceleration is my change in velocity divided by the amount of time that's passed. So that's going to be my final velocity minus my initial velocity divided by my time equals my acceleration. I can rearrange this equation to solve for time before plugging in any numbers. Sometimes that makes the algebra easier. So one handy hint is that if this is all by itself and this is all by itself in the bottom, you can actually swap these two variables. So that's the same as multiplying by time and dividing by acceleration. So rearranging this equation equals, gives me time equals v minus v0 divided by a. If you want to see that in more detail, go look at the previous question in this homework. So time equals v minus v0 over a. So now I can plug in my numbers. My final velocity is v. That's going to be 16 meters per second. 16.0 meters per second. Minus my initial velocity up here is 6.6 meters per second. All divided by my acceleration, and my acceleration is 3.0 meters per second squared. Now, this is a big number minus a smaller number. That's going to give me a positive up top. This is a positive number on the bottom, so a positive and a positive. It's going to give me a positive amount of time, which is always a good thing. Meters per second divided by meters per second squared. Well, the meters are going to cancel out. Seconds divided by seconds squared is going to leave seconds in the denominator of the bottom, and you can see that this is going to rearrange into just being seconds as my answer. So when I do 16 minus 6.6, and you could put a parentheses around there if you wanted to, take that result divided by 3, that's going to give me some number, and my units are going to be just seconds. And again, I'm going to have meters per second on the top, divided by meters per second squared on the bottom. Dividing by a fraction is the same thing as multiplying by the inverse of that fraction. So you divide by meters per second squared is the same thing as multiplying by seconds squared per meter. It's like dividing by a half is the same thing as multiplying by 2. So now meters will go away. My red canceling pen. Meters goes away. Seconds squared on the top, seconds on the bottom. Well, this seconds cancels out one of those, and all I'm left with is seconds, and that's why I have units of seconds, and that is my time. So how long does it take for this acceleration to occur? There's the answer to my problem.